Hello friends, welcome to all of you in Dr. Jaggi's Academy. Today I am going to teach about the electrolysis of sodium chloride. So let's start. We have two types of electrolysis of sodium chloride. In the first case we use a molten sodium chloride and second is aqueous sodium chloride. So the main difference between these two electrolysis, in this case molten sodium chloride, we get a chlorine gas is produced at anode, whereas sodium metal is produced at cathode. In the case of aqueous sodium chloride, we get chlorine gas is produced at anode, whereas hydrogen gas is produced at cathode. So the main difference between these two electrolysis is a difference of product at a cathode. In molten sodium chloride, sodium metal is produced at cathode, whereas hydrogen gas is produced in case of aqueous sodium chloride. So first I will discuss about the electrolysis of sodium chloride. So in the electrolysis of sodium chloride, we use either in molten sodium chloride or aqueous sodium chloride. But however, we don't use a solid sodium chloride. So next question is sodium chloride is not used in electrolysis. Why? The main reason is that there is a strong force of attraction between the sodium ions and chloride ions. So therefore, it does not produce free ions to conduct electricity. So that is why we don't use a solid sodium chloride in an electrolysis. The next one I will discuss the electrolysis of molten sodium chloride. So first of all I will discuss that how do we get molten sodium chloride. The molten sodium chloride is obtained by heating a solid sodium chloride, and in molten sodium chloride we get the two types of ions, that is sodium ions and chloride ions. So next we start the electrolysis of molten sodium chloride. So the electrolysis of molten sodium chloride take place in electrolytic cells. We have a tank, that electrolytic tank, which containing a molten sodium chloride. It means it contains two types of ions, that is sodium ions and chloride ions. To pass the electricity in this molten sodium chloride, we have two electrodes, that is carbon electrode dipped into this solution in molten sodium chloride, and one of the electrode is connected into the positive terminal of the battery and another electrode is connected to the negative terminal of the battery. The electrode which is connected to the positive terminal of the battery is known as anode and it is indicated by the positive sign, whereas electrode which is connected to the negative terminal of the battery is known as cathode and it is denoted by the negative charge. So after passing electricity, this in molten sodium chloride, these ions, that is oppositely charged ions, move toward the different or opposite electrode. It means positive ion move toward the negative electrode and negative ion move toward the positive electrode. So in this case, after passing electricity, sodium ion move toward the, that is cathode or negative electrode, whereas negative ion, that is a chloride ion, move toward the anode, that is a positive electrode. So after reaching at a respective electrode, that is a sodium ion at cathode and negative ion at anode. So as we know that cathode, in this case a reduction takes place. Reduction means gains of electron. So in this case at cathode we have a sodium ions and sodium ions gains electron from the electrode to form the sodium metal. On the other hand, we have second electrode, that is anode. So as we know at anode oxidation take place, means loss of electron. So in this case anode we have a negative ion, that is chloride ion. It loses electron to form chlorine atom, and chlorine atom, as we know, unstable, so it combined to form a chlorine molecule, and so that is why at anode chlorine gas is produced, whereas at cathode sodium metal is produced during the electrolysis of molten sodium chloride. The next I will discuss about the various reaction take place at a respective electrode at anode and cathode. So at anode oxidation take place. So in this case we have a chloride ion that loses electron to form chlorine. Chlorine atom, they are unstable, so it combined with another chlorine atom to form a chlorine gas. Next at cathode reduction take place, gain of electron. So we have a sodium ions at cathode which gains electron to form a sodium metal. So therefore, during the electrolysis of molten sodium chloride, we get a two product. Number one is chlorine gas at anode, whereas sodium metal is produced at cathode. Next I will discuss about the electrolysis of aqueous sodium chloride solution. So what do you mean by aqueous sodium chloride? Aqueous sodium chloride means sodium chloride dissolved in water to form a sodium chloride solution. So in this case, sodium chloride solution have a four types of ions. Two types of positive ion and two types of negative ions. So which are produced during this reaction. We have a sodium chloride which are dissociated into sodium ions and chloride ions. So in this case we have also added the water. So water is also dissociated into H positive ions and hydroxyl ion. So in case of aqueous sodium chloride, so we have two types of positive ion and two types of negative ion. Where we have already discussed in molten sodium chloride, there is only one type of positive ion, that is sodium ion, and one type of negative ion, that is a chloride ion. So in this case, the electrolysis of aqueous sodium chloride, we have an electrolytic tank which containing aqueous sodium chloride. It means it contains two types of sodium positive ion and two types of negative ion. In the case of that is sodium ions, chloride ion, hydroxyl ion and H positive ion. Here we have a two carbon electrode which are dipped into a aqueous sodium chloride solution, and the two electrodes, one is anode and cathode, they are connected to the positive terminal and the negative terminal of the battery. So after passing the electricity, these ions, that is a positive ion which are a sodium ion and hydrogen ion, they are moved toward the cathode, and negative ions such as the chlorine ion and hydroxyl ion, they are moved toward the anode. So after passing electricity, the sodium ion moved toward the cathode, whereas hydrogen ion also moved toward the cathode. After that chloride ion moved toward the anode, and hydroxyl ion is also moved toward the anode, which is denoted by the positive charge. So in this case, that is we have two types of positive ion at the cathode and two type of negative ion at the anode. So in this case, as we know, at cathode the reduction take place, means gains of electron. So at a cathode we have two types of ions, that is H positive ion and sodium ions. But out of these two ions, only H positive ion gains electron, not sodium ion, because the reduction potential of the H positive is greater than sodium ion. So that is why H positive ion has greater tendency to reduce as compared to sodium ion. So in this case, that is the H positive ions gains electron from the electrode to form the H. An H atom that is unstable, it combined with another H atom to form a H2 gas. So here in this case, at cathode, hydrogen gas is produced. On the other hand, we have an anode, second electrode, that is an anode, and where the oxidation take place, means loss of electron. So in this case, we have again two types of negative ion. One is chloride ion and second is hydroxyl ion. So out of these two ions, only one ion, that is the chloride ion, has greater tendency to get oxidized, means loss of electron. So in this case, only chloride ion, they are oxidized, not hydroxyl ion. Hydroxyl ion remain in a solution. So in this case, chloride ion loses electron to form the chlorine Again, chlorine atom is unstable. It combined with another chlorine to form a stable chlorine molecule. So in this case, the remaining two positive and negative ion, that is sodium ion and hydroxyl ion, they remain in a solution and to form a sodium hydroxide solution. So in this case, during the electrolysis of aqueous sodium chloride, we get two products. One is hydrogen gas is produced at cathode and chlorine gas is produced at anode. Whereas in this electrolysis also used for the production of sodium hydroxide. Next reactions take place at the respective electrode. At anode, oxidation take place. We have a chloride ion. They loses electron to form a chlorine. Chlorine they are combined with each other to form a chlorine gas. At cathode, reduction take place and we have a H positive ion gains electron to form the hydrogen. Again, hydrogen atom is unstable. It combined with another hydrogen atom to form the H2 gas. So in this case of electrolysis of aqueous sodium chloride, we get two products. Chlorine gas is produced at anode and hydrogen gas is produced at cathode. So these are the electrolysis of molten sodium chloride and aqueous, and we have studied what is difference between these two electrolysis and what are the product difference between these two electrodes. And in upcoming video we will discuss about the electrolysis of water. Thank you.